Truth. All right. Okay. Evening, everybody. Sorry. All right, folks. So let me just take my role real quick, right? D'Angelo here, Donovan here, Juliana should be late. Hanifa is here, Jaden here, out. Javier, I know Javier. Jaziri here, Jolie Khalifa, Noah, Nyla, Page. Right. Okay, cool. Well, we'll see who else pops in. In the meantime, right, so what we want to do today, guys, we want to wrap up the Jan 2023 paper 2. And like we said, we want to start some topics. And the first topic you all talked about was coordinate geometry, right? So let's take a look at this question here. We have question 9C and question 10, which is some matrices and some vectors to do, right? And then we will see how to progress from there, right? Now, Google Meet, if you all ask any question, anything, and I don't hear you, make sure I hear you, all right? Okay, so the first thing to do is, of course, take a read of the question and see what's going on, right? Let's do such. So the diagram below shows 4 points, P, Q, R, and S on level ground, where pillars will be placed to mark the outline for a foundation. Okay, P, Q, R, and S. P, Q, R, sorry, R, and then S. Wow. Okay, cool. Okay, now we have a shape here. So if we ignore this line in the middle here, right, we have a quadrilateral. Can you all see the quadrilateral? Where's it? Seen it? All right. But if we put that line back in, we cut the quadrilateral into 2 triangles. Very good. In one of the triangles, we have 1 angle and 1 length. In the other triangle, we have 2 lengths, right? Now, in each case there, unless this triangle was a 90-degree triangle, the information is currently insufficient to find anything else. All right? Now, it says there's a vertical post RT at R. So what's going on here, guys? And this is something they haven't brought in a while. What I like to call a 3D question, where you have flat ground and you have a pole coming out of flat ground, but you have on the flat ground this diagram. So what's going on here? Let's put that one in orange, right? Right? So you have here a pole coming out of the ground, and we call that, well, the top of it is T, right? T for top. Just give me 1 second. Let me see who's that came in the gate there. I don't know if there's anybody else. All right, cool. There we go. Right, so that orange line there, T, is coming out of the ground. It's going into the ground at a 90-degree angle as well. All right? And all those other lines that we see in there are on flat ground, right? So you have to kind of try and get the perspective, right? Now, it goes on to say some other things. There's a vertical post that, right? From Q, the angle of elevation to the top of the post T is 21 degrees. So from Q, right, there's an angle of elevation of 21 degrees to the top of the post, right? And they wanted to find the height of the post. So what we're going to do first is we're going to sketch. Actually, I didn't give you enough room, right? So let's come down here and we're going to sketch over the diagram real quick, right? Oops, sorry, that's not what I meant to do. All right, so at this point across here, you have R, this is T, this is Q, you have 21 degrees, and we have 1 length. The length we have is Q, is from Q to R, and that length is 153 meters, right? And what they want us to find is the height, RT. Okay, now in a regular right angle triangle, what ratios, what is available to us? Pythagoras or SOHCAHTOA, sine, cosine, and tangent, right? Now, how do we know which of these 3 ratios to use? You have to analyze the diagram you have, right? So let's zoom in a little bit more. So relative to the angle, the length that we are looking for is the opposite side. This side opposite the right angle is the hypotenuse, which means that the one length that we have is the adjacent side. Now, we're looking for the opposite. We don't have, nor are we looking for the hypotenuse, and we have the adjacent. So which one? Right. So sine, if it was sine, that would be opposite over hypotenuse. But that's not what we're doing. Right? Because look, we aren't looking for, nor do we have the hypotenuse. It would be so cosine is adjacent over hypotenuse. And again, we neither are looking for nor do we have the hypotenuse. So by default it's tan, right? Opposite and adjacent, right? So the tangent of the angle is the ratio of the length of the opposite side to the length of the adjacent side. Okay, let's do the working in green so it kind of stands a little bit more, right? Okay, so the tangent of 21 is equal to the opposite side, RT. So that 21 looking like a 4. Give me one. Hey, AI, I didn't ask you to come up. AI, behave yourself. Tan 21 degrees is equal to RT over 153. So how do we solve for RT here? We would multiply by 153 on both sides of the equation, right? So when you multiply on both sides, you remove it as a denominator, and you essentially make RT the subject of the formula. And all we have to do now is plug it up in our calculators, right? So therefore, RT, sorry, would be approximately. Let's take a look and see what it is, right? So that's tan 21 by 153. So 21 tan by 153. So about 58.7 meters. You smiley, nobility, KK, guys on tonight. All right. All right, Donovan and D'Angelo, if you guys are good with that, just kindly give me a quick Genie chat, please, and thanks. Can you need me to re-explain, give me a R. All right, thank you guys. Ladies, are you all okay with how we found the 58.7 meters there? You okay with that? All right, cool. All right. Now the last thing, it says that given that the length of QS is 135, find the perimeter of the foundation. So QS is this. So let me put that in a little yellow highlight, right? So this. Oh, good. That a little too small. Let's go back here. Look and see that. The yellow. You seen it? Oh no. All right, cool. So that's QS, right? And they said that given that the length of QS is 135, so that's 135 meters, right? Calculate the perimeter of the foundation PQRS. So the perimeter will be the total distance around, right? Now we have 3 out of the 4 lengths. We have PQ, which is how much? 83. We have QR, which is 153. Right? And we have RS as 110. What's the only length we don't have here? Maths is Monday and Wednesday, 6:30 to 8:30. It's PS, right? Now, the yellow line is not part of the perimeter because the perimeter is the total distance around, and that is on the inside. So we're not adding the 135. It doesn't form part of technically of the calculation of the perimeter. But we need to find this length here. Now, that length exists in this triangle PQS. Is triangle PQS oh yes, KK, that's correct. I know Silicon. Yeah. Is PQS a right angle triangle or a non-right angle triangle? None, right? So we can't use basic SOHCAHTOA, but we do have available to us either sine rule or cosine rule. Now the setup for cosine rule is if we have a triangle and you have 2 adjacent lengths and the angle between, we could find this length down here, opposite the angle. Right? Do we have that item? Do we have that set up? Do we have 2 adjacent lengths and the angle between? Right, we do. And are we looking for the length opposite that? We are, right. So let's get it. So this is vertex P and the length opposite is length P. This is vertex S, that length would be small s. And this is Q, which means the length opposite would be small q. Right? So using cosine rule, we're looking for Q squared. That'd be equal to what? P squared plus S squared minus 2 by P by S cosine angle Q. Okay. Right. So what I'd like you guys to do for me, please, is using the cosine rule and the values of 83, 135 for the length, and 29 for the angle, sub them in the formula there, the equation there, and solve for the value of Q. Wood. YouTube. All right. Three people. All right, no problem. You guys check it out. With more than 5 friends. Thanks very much. Lemika, thank you too. Lizzie, thanks for the follow. Sham, remember Sham was about the email? Right, I got an email from the only Sham, and it said that's a good afternoon, study to help. So you said, what's happening? Right. E squared, 35 squared, 83 squared, minus 2 by 135 by 83 by cosine 29. Right? So you could, do I have keep? You don't want to count paper answers. Right. The answer is yes, but they're in a mess. I didn't do a very good job in filing them. But I also have what's called a school.com community. Small subscription fee of 30 US or 200 TT per month. And I have my recordings from my Unit 1 class posted there. I did mainly Module 2 and Module 3 stuff. And the past papers are kind of used to teach. Hey, Denise, how you doing? Check it out if you're interested. You can just subscribe for 1 month, binge all the content, and then unsubscribe. You don't have to stay on and spend money unnecessarily. Unless it's like to support the channel. In which case, thanks. Yeah, but the like the hard copy, use the PDF something. Yeah, they're all over the place. I say I know where they are, but to sort them right now is not a priority, unfortunately. Oh, you got ones in both maths and accounts? That's excellent. Congrats. Cool. That's 5 years ago. Wow. So what are you doing now, Reed? So if you went on the Cape, you would have finished Cape in 2022. So you're finishing university now. It would be meters squared. Because cool. Right. So 135 squared plus 83 squared minus open brackets 2 by 185. Sorry, not one. Oh crap. 135 squared plus 83 squared minus brackets 2 by right 135 by 83 by 29 Cosine. Boom, bam. So 5,513, right? So 5,513 point dot dot dot, right? So that's q squared. So to find q, we have to undo the square. How do we undo a square? By finding the square root. So 5513 dot 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 square rooted. So keep the value in your calculator and express square root, and here you get 74.25 meters, right? 74.25 or 74.3 meters. Sorry? 74 could work too. Right, but we're not done because we have to find the perimeter of the foundation. Eh? So what we have to do with that 74, we have to add it to 83, 153, and 110. Oh, yeah, you okay, cool. What degree you pursue? I did management studies all the way back between 2000 and 2003. So I left you quite some time ago. All right. Okay, cool. So therefore, to find the perimeter, right? So you can say PQ plus QR plus RS plus SP that we just, oh no, we just found QS, right? Oh no, hold on. No, we found PS, right? So PQ is 83. That's 83. QR is 153. RS is 110. So 153 plus 110 plus the 74 we just found, right? That's 236, 346, 350, 420. Anybody? You got the perimeter? All right, 420 meters. All right. Biocheck. That's really cool. I had a friend who wanted to buy a camera real bad, but she ended up going to me, and she's a doctor now. She's a pediatrician now. Times in school. Yeah, that's true. Yeah. All right. D'Angelo Donovan, if you guys are good with that, just kind of give me a quick genie chat. Right. If, of course, you want to send me pics of your weekend, please feel free to do so. Right. D'Angelo. Okay, cool. Ladies, you're okay with the cosine rule and then the final working down here to find the perimeter? Any questions? Anybody? Anything? No? Okay, cool. All right, so I'll give you a minute or so to finish copy down. I mean, switch up to question 10, right? Vectors, matrices, and then we'll see how we go on with that. All right, let's switch it up. So question 10. So three matrices Q, R, and S are as follows. So let's analyze these matrices to find the order, right? So we have Q has 2 rows and 2 columns, as does R. So the order of each of those matrices would be what? The order of Q and order of R would be what? 2 rows by 2 columns, 2 rows by 2 columns. What about S? You have 3 rows, but still 2 columns. So good. So you have a 3 by 2. All right. Now, the first question they ask here, oh, very good. I don't know what these symbols mean, so I don't know how to pronounce your name, but if you let me know, I will happily pronounce your name correctly. Right. So explain why it is not possible. So QS. So if you multiply Q by S, you're multiplying a 2 by 2 by a 3 by 2. But for matrices to be compatible for multiplication, these two numbers have to be the same, right? As in the number of columns in the first matrix have to be equal to the number of rows in the second matrix. Because if you were to multiply row by column, it multiply 2 by 2 minus 1 by 4, but then it have nothing to multiply by minus 8. So that can't work. For matrices to be able to multiply, you have to have equal numbers of elements along the rows in the first. So if there was a third element here, then you could do it. So you have to have the same number of elements along the rows as down the columns in order to be able to multiply. Right? So you could say in different ways. You could say that the number of elements along the rows of Q, right, is not equal to the number of elements down the columns of matrix S. All right, so you could say like that, or you could simply say the number of columns in matrix S is not equal to the number of rows in matrix R. Sorry, in matrix. Sorry, the number of columns in matrix Q is not equal to the number of rows in matrix S. Right? It's a shorter way of saying the same thing. Right? Hey, Anderson, what's going on? Oh, sorry, definitely not Anderson. Right? Natalia, thanks for joining live. Here, thanks for joining live. And Dot as well. Bite size lessons, what's going on? Good to see you. All right. Now the next piece says state the order of the matrix product SR. So if you have SR, you'll be multiplying a 3 by 2 matrix by a 2 by 2 matrix. So the first thing first is that these two numbers are the same. So the matrices are compatible for multiplication. And we can know what the resulting matrices order would be by taking the number of rows in the first matrix and the number of columns in the second matrix. So the resulting, so matrix products are the order of SR is 3 by 2. The number of rows from the first matrix S, right, and the number of columns from the second matrix R. Hey, Ayana and Zian, thanks for the follow. Appreciate it. Okay, D'Angelo and Donovan, just give them a quick G if you guys are good with these first two pieces, please and thanks. Right, now we're going to actually do a matrix product. All right, ladies, you're okay with the statements here? Yeah? Any questions? No? All right. CPU. Which part CPU? 1 or 2? Thank you. Symbols. I don't know what name to put. Right. All right, let me come back to that, right? In a second, right? So why can SR be multiplied? Because if you look at SR, right? Hold on, hold on. What's the next one? Oh, it's QR, right? So if you multiply an SR, you have 2, 7, 4 minus 1, minus 8, 9, and then multiplying it by 1, 6, minus 5, and 4, right? So if you look along this row, you have 2 elements, and down this column, you have 2 elements. So if you do 2 by 1 and 7 by minus 5. So each element along the row in matrix S is matched up against one and only one element in the columns of matrix R, right? And you could repeat it for any of the rows. This row has 2 elements, and this column has 2. So the 4 will multiply by 1, and then minus 1 by minus 5. Then minus 8, 9, and 1 minus 5 can match up. Minus 8 by 1, 9 by minus 5. Right? So that's why they can be multiplied. All right? Okay. Now, in the third item here, they want the matrix product QR. So that's 2. Okay, so I'll write over the matrices down here, and I'll give you a couple of minutes to sort it out, right? I guess we could do this one. All right, so matrix Q, what was it? It was 2, minus 1, 4, and 3. Is that visible enough? Okay, cool. All right, CPU. Okay, good. Glad to hear you're good with no CPU. Paparazzi, what's going on there, buddy? It's flashing. Multiply by R. R is 1, 6, minus 5, 4. Thanks for the follow. Appreciate it. All right, cool. So what I'll do is I'll do the first set of stuff here, right? So again, you'll do first row by first column, right? And it'll match up to this item here, the item in the position first row, first column. All right, so it'll do 2 by 1 and then minus 1 by minus 5. All right, so it'll do 2 by 1 plus minus 1 by minus 5. All right, so now you could do the rest. What goes here, what goes here, and what goes here. So I'll give you. Can I explain back 2, please? Right. So this is the steady order. So this matrix here is a 3 by 2 matrix. You have 3 rows and you have 2 columns. And here you have 2 rows and 2 columns. So that's a 2 by 2, right? Now, if these two numbers are the same, then the matrices are compatible for multiplication, because when you multiply matrices, you multiply in rows by columns. And you have to match up each element in the row to an element in the column, right? So, and there must be no elements left over or unmatched. So the 2 multiplied by the 1 and the 7 by the minus 5. So you see each element in the row matches up to an element in the column. And each element in the column is matched up to an element in the row. I said you can do 2, 7 by 6, 4. 2 by 6, 7 by 4. All right, and then you keep saying second row, first column, 4 by 1, minus 1 by minus 5. All right, so I hope that helps. It's smiling. So we'll see the working down here just now too. Here is Sean and Kelsey. Thanks for following that. And Teresa, thanks very much. All right, all got true? All right, cool. Right, so now let's do the same first row, but the second column. So that'll be 2 by 6 plus minus 1 by 4. All right, so 2 by 6 plus minus 1 by 4. All right, and now let's do the bottom row by the first column. So 4 by 1 and 3 by minus 5. 4 by 1 plus 3 by minus 5. Right, and now let's do that by that. So it'll be 4 by 6 and 3 by 4. All right, cool. Was Antrimon. I appreciate the follow very much. Okay, so now let's work out each set of those individually, right? So 2 by 1 is 2. A minus by a minus is a plus. So 2 plus 5 is 7, right? Across here now, 2 by 6 is 12, and minus 1 by 4 is minus 4. 12 minus 4 is 8. Down here now, 4 by 1 is 4, and 3 by minus 5 is minus 15. 4 minus 15 is minus 11. Jody, well, Jody looking good so far. Only have one more element to go. Thanks very much. Minus 11. Yeah, minus 11. That's good. Right? 4 by 6 is 24, and 3 by 4 is 12, and 24 and 12 is 36. That's good. Yes. So, Jody. Minus 36? Not minus 36, just positive. Check it again. See, it was 4 by 6 and 3 by 4. 4 by 6 plus 3 by 4. 4 by 6 is 24, and 3 by 4 is 12. All right. Okay. Where was we? Right. Okay, D'Angelo Donovan. Give me a quick G if you guys give me the matrix multiplication, please and thanks. All right, good. Thank you. So, except, oh, sorry. All right. I like it. Somebody phone buzzing. All right, cool. Mark your work for you. Hey, Sham, I'm in a class right now, boy. That's why I take another response. Yeah, boy, here now. Things real busy right now. I don't have any extra time. Even anybody need for one-on-one. Real sorry. And even the person who works with one-on-one clients with me, he out of the country right now. So the most I can tell you, boy, is you had to go through the YouTube channel piece by piece, bit by bit, right? You can email any questions you have. I'll see what I could help. But that's why I put the channel up there. I put the channel because I can't help everybody individually. I wish I could, but I can't. Right? And the channel is free, as you know, right? The lessons not free. Sorry about that. You know, but best of luck, buddy. Take your time, go through things one piece by piece, one by one, and you could get through. You could get through. Okay. Yes, positive. Right, there you go. Okay, ladies, we okay with the matrix multiplication? Anifa, Khalifa, and Jolie? We okay with it? Right? So if we had a I, so it's because H I J K. Yeah. Yeah. Hanifa is H. If we had somebody with an I, and Jolie is J and Khalifa is K. Okay. Yeah. And then Logan was the L. Yeah. Yeah, why not? Right. And then Page is P, right? Q. We don't have any Qs though. Yeah. No. All right, cool. There we go. All right, check it. Given that A is 4 minus 1 minus 7x, determine the value of x when. So what does this thing mean here? That is the determinant of A. Now, how do we find the determinant of a matrix, a 2 by 2 matrix? You multiply 4 by x, you multiply minus, and then you subtract, right? So the determinant of A is equal to 4 by x minus 1 by minus 7. And it told us that is equal to 5. Okay, so with that now, right, Jody, very good. Yes, Jody. Right? So if you have a generic matrix M, right, and the matrix M has elements A, B, C, D, right? The determinant of M, which is M between two vertical strokes, is equal to A multiplied by D minus B multiplied by C. Right? Yeah, Judy, you good to go there. Oh, here's Julie. Hey, Julie. Even how you doing? Right? We finishing off the Jan 2023 paper 2 here. We did the tricks question. We're tackling some matrices here. We have the vectors after. And after we're going to switch up a little bit. Because the basically we kind of pivoting to, instead of doing whole papers, we're going to do topics. So we're going to try to do as many particular questions on a particular topic in each session going forward. All right? I can hear you now, yes? All right, cool. Sorry, say that one more time. Yeah, going forward. Hello, wife. How are you? Yeah, Julie. So I kind of was doing that with my POA class, and I'm like, well, maybe we could do it for the maths class too. So yeah, so I'll pull out some coordinate geometry questions that we're gonna start today. We have to take a poll and see if anybody wants to come to class on Monday, because Monday's a holiday, as is Tuesday. So we'll see how that goes. And if we do have class, it'll be earlier. It'll be like 1 o'clock to 3 o'clock in the afternoon, if we have class. Right? Anyhow, yes. Oh yeah, babe. How the boys going? Everybody all right? AC9I. CJ, thanks very much. All right, cool. Right. So what's 4 by x? That's just gonna give us 4x. Minus 1 by minus 7 is what? Positive 7. But then it's subtracting that. Everybody good? Okay, that's what I have. And that's equal to 5, right? Okay, so how do we solve for x here, right? If 4x minus 7 is equal to 5. Right, so the first thing to do is you'll add 7 to both sides, right? Because whatever happens to one side of an equation must happen. And of course, to get x by itself, you have to remove everything currently attached to it. And to do so, we have to use the opposite of the operation that attaches the item in the first place, right? So first things first, we'll add back the 7. So when you add 7 to minus 7, it'll cancel the 0, leaving us just the 4x. 5 plus 7 is 12. And now, how is the 4 attached to the x? Multiplication. To remove something attached to multiplication, what do? We need the opposite operation, which is division. So we'll divide by 4 on both sides. 4x divided by 4 is x, and 12 divided by 4 is 3. That's the value of x. Right. Okay. Okay, cool. So D'Angelo, Donovan, and Julie, just give me a quick G in the chat if you're good with that. Honey, for you okay with that? All right, cool. Okay, so we have a few vectors questions here. All right. So the first thing, yes, CPU. Good. Thanks for letting me know. Right. In the diagram below, OPQ is a triangle. OPQ is a triangle. ARB and AOQ are straight. So ARB is this line here. AOB this line here. Everybody okay across there? You sure? I sound like you're choking there, boy. Right, cool. Right. So those ARB and AOQ are straight lines. B is the midpoint of PQ. B is the midpoint of PQ. What does a midpoint do to a line? It cuts it into two equal halves. So PB is one half of the whole line, and the whole line is PQ. And BQ is another half of the whole line, PQ. All right, cool. All right, so now R is the midpoint of AB. R is the midpoint. So R divides AB again into two equal halves. So this piece here is a half of the larger line, AB. And this piece here is again a half of the larger line, AB. YL and Naomi Genesis is right. Thanks for the follow. Appreciate it very much. Okay, right. So we have that. And then this piece here, OR to RP is 1 to 3. OR to RP is a 1 to 3 ratio. Right. Now, when you have a ratio, what do we do with the numbers? You add them. So 1, hold on. All right. So 1 plus 3 is equal to 4. And then we put each of these numbers over that total. So what that means is that when you break up the larger line OP, right? Let me take off these lines here, right? Right? When you break up the larger line OP by placing R on it, what you've done is you've broken it up into a 1/4 and a 3/4, right? Because this tells us that RP is 3 times OR, right? Or OR is 1/3 times RP. But of the larger line OP, they are each 1/4 and 3/4 of the larger line on which they lie. All right. So this is 3/4 of OP. Sorry, this is 1/4 of OP down here, and this is 3/4 of OP. Okay. Now they go on to tell us OP is 4A. So this whole line here is 4A. So the whole line is 4A, and then OQ is 8B. OQ here is 8B, right? OQ, right? And OR is 4A. I feel I should have used different colors for this now. All right, cool. Now find in terms of A and or B in its simplest form what they want. They want PQ, PR, and RB. Was that for dog? That for long hot dog or? Okay. So PQ. So we have plenty of things going on there. So let me actually take off some of them. Right. Okay, cool. Right. So OP is 4A. OQ is 8B. Right? this and this are equal in length. This and this are equal in length, right? What time you finishing? 8:30, so about an hour again. Right. Right. So we want to know how to go from P to Q. Right. Now we could only travel along the lines for which we have vectors. We only have two. If you put the volume down, it would cut the feedback. Yeah. Right. So we only have two vectors. We only have two lines along which we have vectors. Right. So here what I'm gonna do. I'm gonna put those lines in some different colors. Right. 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 Okay. Cool. Right. So we have just two lines for which we have vectors: the pink line and the green line. The pink line goes from O to P. So that vector OP is 4A, right? As we could see to the top left-hand side. Wait, where RB went? It's not RB they wanted us for the last thing? Right, cool. So, yeah. So how do we get from P to Q by following only along the lines for which we have vectors? We have to go from P to what other point first? We have to go from P to O, and then we could go from O to Q. So PQ is equal to PO plus OQ. Now, to go from P to O, if you look on the pink line, right? Right, the arrow along the pink line, arrow along the pink line is traveling upwards from O to P, but we want to go backwards from P to O. So if you want to go backwards, so you have to invert the vector, right? Right. So PO, right? To go from here to here is the inverse of OP, right? And to denote the inverse of a vector is simply put a minus sign in front of it. OP. Right? OQ, we're going in the same direction. All right, cool. Right. So that'll be minus 4A plus 8B. Long story short. All right. Now for PR, right, PR. Right, please redo. So is this live recorded? Yes, it is. All right, okay, so let me go over PO one more time. All right. To go from P to Q, we have to travel. We can only travel along the lines for which we have vectors, which are the pink line and the green line. The pink line is OP, right? Going on the, and as you can see, the arrow is going up from O to P, right? So that's the direction of that vector, right? And we have OQ going this way, again indicated by the arrow here. Now we want to go from P to Q, and we can only travel along the lines for which we have vectors, right? So if you follow just the points, right, the easiest way to travel to go from P to Q, and the only way we could currently do it, is to go from P to O, and then from O to Q, right? So that's the first protocol, the big letters, P to O, and then O to Q. So that's captured here. So PQ is PO plus OQ, right? And you know the common point in between, right? The ending point of the first vector, O, is the starting point of the second vector, right? So P to O and then O to Q. It's already live on YouTube currently, and the live stays up for a couple of days. So be sure to check it out quickly before it comes down. Yeah. Right. Now to go from P to O, we're traveling in the opposite direction of this arrow. Right? We're traveling in the opposite direction. Okay, cool. Right. So going this way, the vector given to us by the question up here is 4a. That's just what it is. So to go backwards along the vector, we have to invert the vector. And to invert the vector, all we have to do is put a minus sign in front of it. Right? So PO is simply minus OP. Right? And then after we get here, we just have to go from here to Q. Right? So we have minus OP plus OQ. Minus OP is simply minus 4A. And then OQ is just 8B. Right, cool. Ladies, we okay with part one? Any questions, anything? All right, D'Angelo, Donovan, and Julie, give me a quick G. If you're good with the first part, please and thanks. All right, thank you. Right. Okay, now the next one I want is PR. Now, PR simply goes from point P to point R. That's traveling on what line is that? On what larger line is that traveling? It's traveling along the pink line, which is OP or PO, right? Now it's going from P to R. So is it going in the same or the opposite direction of the vector along the line? Opposite, right? Next question: is it traveling the whole length of the line, longer than it, or shorter than it? It's traveling part way along the line, right? And that's where this stuff in the yellow, correct, right? They told us here OR to RP. So the ratio OR to RP is 1 to 3. And what we do with the ratio is we add the numbers together. That'll give us 4. And then we put each of the individual numbers. So it was a 1 to 3 ratio over the total. And these fractions are the fractions of the larger line on which those pieces lie. Right? So OR, right? So OR is just this segment down here. And that's 1/4 of the whole pink line, right? And RP is this larger segment up here, which is 3/4 of the whole line. All right. So PR is equal to, right? So it's 3/4, right? It's 3/4. So come on, man, Philip, give yourself. 3/4, fraction, 3/4 of PO. And we know that PO is the inverse of OP, 3/4 of minus OP. Right? So that's 3/4 multiplied by minus 4A, which is just minus 3. Right? So you're just going right here. You don't have to put all that, you could just put 3/4 of PU and then just, but you should at least show one extra step in there. Right? Like this, and then that. All right, cool. Right. How did you get 3A? 3/4 of 4A minus 4A. Right? You can put the minus 4A over 1, and then 4 will cancel it 4 one time. All right, B? All right, cool. Right, and the last part I want is RB. Right? So RB, let's put that in an orange, shall we? We can't do orange before. Crap. All right, so we gotta do a different. Maybe purple. RB, right? Yeah, RB. All right, cool. OPQ is a triangle. ARB and AOQ are straight lines. B is the midpoint of PQ. R is the midpoint of AB. All right, cool. So check this, right? Now RB lies on what larger line? AB. And because we know R is the midpoint of AB, we know RB is a half of the whole of AB. But the thing is, we don't have any information about A. We don't know what to get from O to A, nothing like that, right? So what I would encourage you to do here is to, again, from R, how do we get to B? We could go from R to P, and then from P to B. All right. You could go from R to O, O to Q, and Q to B. It is more work, yes. Yeah, that's the easier one to do it. That's correct. Right. So let's go with the big letters first, right? So how we do in RB is we are doing R to P, and then plus P to B. Now, what do we find just now? We found PR. What is RP relative to PR? The opposite or the inverse, right? So, and to invert a vector, all we have to do is put a minus in front of it. So, as minus PR. And now PB. We know B is the midpoint of PQ, which means that this piece here is what fraction of the whole line? A half of PQ. And we have PQ from part one, not so? Okay, so I want you all to plug in the letters and do the work. PR is already negative. Plus a half of minus 4A plus AB, yeah. Right? So it will be right. So minus 3A plus a half of because we said it's minus PR, right? PR is minus 3A. Right? We explain part 3 so if possible. Right, okay. So we want to go from point R to point B. To go from R to B, we could simply go from R to P and then P to B. So that's how I got this piece here. All right? Now, RP is the inverse of PR. If you notice, the letters are simply flipped, right? Sorry. Right? So RP is the inverse of PR. And how we denote the inverse of PR is by simply writing a minus sign in front of it. All right? And then PB, to go from P to B, right? Because it told us that B is the midpoint of PQ, which means that to go from P to B is moving halfway along the whole vector PQ. So that's why I put that PB is a half of PQ. And in part one, we have PQ, minus 4A plus 8B. Right? So minus PR, if PR is minus 3A, minus PR is minus 3A, which just gives us positive 3A. And then a half of, so PB is a half of PQ, and as a half of this. A half of minus 4 is minus 2, a half of 8 is 4. All right, and 3A minus 2A is just 1A, and then that's just 4B. All right, so Donovan, Juliana, D'Angelo, if you guys are good with the vectors, give me a quick G. If you need me to re-explain any or all of them, give me a R, and then tell me specifically what you'd like me to re-explain. Okay, great, thank you. All right. Scipio, talk to me. Good then. Nico, Mr. Roy, Sally, Ashok. Who's the other one? Kalisa. Was that Zena there? Zane, sorry. Ali. Bubbles. Bubbles. Survives. You good now? All right, cool. All right, no, okay, cool. Oops. All right, guys. All right, that's the end of the paper, guys. Give me 1 second. Uh-huh. Yeah, Julie, you could do that. R O O Q and QB. So then you would have minus a quarter RP. So minus A plus 8B. And then you have to do minus a half PQ. You could do that too. It's supposed to give back the same thing. Uh, okay, thanks. Cool. All right. Yeah. So, folks, that's the end of the Jan 2023. Now, the request was that we focus on topics going forward. And the first topic requested was coordinate geometry. So what I did was, I mean, obviously we can't work every single question in coordinate geometry for all the past papers because then we would run out of time to work other things, and there are many other things that you would work. All right. So we're gonna start. Yeah, because I kind of feel like we should start with the questions tonight, and we'll continue now. Again, Monday's a public holiday, but I do have. I had to talk to my wife and see what's going on. So possible I might have a class on Monday, but it will be earlier, like 1 to 3, especially if I have a POA class 10 to 12. I don't know that that would happen because we have some family in from Canada, and they might want to line and do things on the holiday. I know my mom wants to go to the beach. I just don't know what day she wants to go. So, we have to organize that. Okay, right. So, folks, here we go. Um, I'll close off some stuff here, boy. I'll leave the introduction for now. Right. Okay. So, folks, I did open up. Wait, where did it go? Yeah, I did. Hold on. What is this now? Okay, so I have some questions here. And the larger PDF is 24 pages, so I can't print out all that in one go in the middle of a class for 3 people. That doesn't make no sense, right? But what I did is I compiled all the past paper questions in coordinate geometry between 2016 and 2025, right? 2015 had none in either May or January, which is kind of weird, right? But I was supposed to go through and pick out a specific order in which we would do the questions. I didn't get a chance to do that. But what I'll do, I'll kind of just do it on the fly. All right. So I feel we could bypass this first question for now. All right. All right. So I feel we could start with this one. This one, boy. Uh-huh. And what they want us to do. Equation was the relationship. Okay, cool. Let's start here. So let me actually just print out these 2 pages for those in class. Those online, you'll have to follow what's on the screen, right? I do apologize. Okay, somebody kind of huff money printed it. Wait, what happened there now? Did it shut off? In the middle of printing something? Let's give him a minute. Wait. Yeah, but it shut off. It printed it, it went to flip it, and then it just died. Are you started? Yeah, as all right. So we could still see the question, right? Okay. All right, hold on. Let's know. Let me actually get a different section going here, right? New, yeah. Browse. No, let's go to lesson plans, maths. Let's go into coordinate geometry. Where'd it go? Okay, yeah, open it. Press, yeah, let's press OK. Oh, hold on.
Oh my god, I was just coming a little bit early. So like it will be that's okay. Yes.
Yeah, no, because that is good. Hey guys, sorry, just give me a second. So, all right. All right. One sec. Options. Play. Oh wait, where'd it go? Cool. This is what? This is May 2017. All right, cool. Okay, cool. All right, guys. And so there have a couple other pieces that I'll write out if anything, right? One equation of line L1 and okay, cool. All right, okay. Let me see if I could print that out for you guys real quick, right? All right, give me a sec, sorry. All right. Let's see if it works. Printer, are you printering? All right, okay. It seems to be working now. Let me just distribute it to the three girls here and then we'll continue. Monsieur Molino, continue. Le bibliothèque. All right. Hey guys, sorry about the delay. It's just technical difficulties, usual thing. Is that me? Nope, not me. I'm on silence. All right.
I'm back in. I have you told me 6 times.
All right. Hey Roxy, didn't know how you're doing. All right, folks. So sorry, after that long wait time, right, let's start. Okay, so with coordinate geometry, right, we are on the coordinate axes. Let's zoom in a little bit, right? So it says that the graph below shows two straight lines, L1 and L2. So for the purpose of making these things a bit more visible, what I'm going to do is I'm going to put some color on this, right? So this first one I'll put in pink, right? And the next one I'll put in green, right? Okay, cool. Okay, it didn't want to convert to a straight line. Weird. Okay, right. So I think those are two nicely contrasting colors. Oh, you're good? Oh, lovely. Are you doing maths this year? Right. Okay. So we have this pink line and this green line. So the first thing they want is calculate the gradient of each of the lines, L1 and L2. All right. Now, let's get a different color, right? Yeah, let's do that. Right. So the formula for gradient, as we know, gradient is notated as m. And the gradient is the change in y, so y2 minus y1 divided by x2 minus x1. So what it means is that we need 2 points on each line and the coordinates there, right? So I'll do L1 as an example, and then let you guys try L2, okay? So for L1, right? So the easiest points to do, right, are the points where the line actually cuts the major grid lines. The major grid lines being the slightly thicker or heavier points. So for example, let's call this point here point A. If you read down to the x, that's between 4 and 6. So what value is that? That's 5. And if you read across to the y, that's between 10 and 2, which is what? 11, right? So for point A, which we are calling it point A, the coordinates are 5 and 11, right? And we could take this point here, we could take this point here, this one, or that one. We could take any of those points, right? So let's take this one down here, shall we? So if we go down here, we have 1, and if we go across, we get 3. So and let's call it point B, right? So we have 1, 3. Right, so we could call this one x1, and this one y1, this one x2, and this one y2. And when you plug it up into the gradient, so let's say gradient 1, right? So y2 as the 3, so you could do 3 minus 11 over x2, so 1 minus 5. 3 minus 11 is minus 8, 1 minus 5 is minus 4. And a minus divided by a minus is a plus. All right? Okay, cool. So what I want you to try now is I want you to do the gradient of line L2, the green line. All right, so what points might you use here? You could use this point, you could use that point, this one, all of those, any of those. All right, so you can pick any of those points, right? Plug them into the gradient formula, and you'll get the gradient. Right, let's go. Another half. All right, that's close. Okay, so let's pick which point. So what coordinates did you guys use? Okay. Yeah. So 2, 5. All right. And I said 6 and 3. All right. So 6 and 3. And I said 8 and 2. 8, 2. Okay, cool. All right. Okay, so let's I'm just gonna pick a couple of points, right? So I will use this point here, which I'll call points. Oh no, I can't call it C, sorry. So let's call it D. So that is 10 and 1, right? So point D has coordinates 10, 1. All right, and let's take this point, let's call this point E, which has coordinates 4 and 4, right? All right, so the gradient of line 2 would be equal to 4 minus 1 all over 4 minus 10. 4 minus 1 is 3, but 4 minus 10 is minus 6. So what we would get is minus a half. Right, so minus a half, not just plain old half. Right? They were close. Right, so keep looking at it. All right. Where did come up with these names, host? I said that one out loud. I'm choking. I don't drink some water. Cassie 60. That's a nice one. Cassie 60. Cassie, what vibes? You good? All right. So are we okay with 2 and minus a half, ladies, for the gradients? You okay with those two? All right, cool. But you saw how I got it? Are you okay with that? Sure. Okay, Hanifa, what about you? You okay with that? Julie? No? All right. Which points did you use? You forget, but look down. Yeah, I'll go over now. Huh? All right, so you use 2 and 5. So that's this point. Okay, let me take off some of these extra lines on there, right? So it's kind of visually cluttered right now. Okay, so you said you use 2 and 5 and 10 and 1. So that's this point here, right? So 10 and 1, right? Okay, cool. 1 second, sorry. Right, so 2, sorry, let me use a different color so we could distinguish it, right? Purple. Right, so your coordinates were 2, 5, 2 on the x, 5 on the y, and 10 on 1, right? So this is your x1 and y1. This is your x2 and y2, right? Minus 0.5 is perfectly fine. Right. So what's your formula, Julie? Gradient is equal to the change in y, y2 minus y1 all over x2 minus x1, right? So 1 minus 5 over 10 minus 2. 1 minus 5 is minus 4. 10 minus 2 is 8. And 4 goes into 4 one time, and 4 into 8 two times. Because you're smart? Why? Yeah. Because if you also, how you could tell if it has a negative gradient is it then sloping downwards going left to right. So as x is increasing, y is decreasing. So that means you have a negative gradient, right? For the other one, if x and y both increase, then they have a positive gradient. All right. Cassie, did that help at all? All right. So Donovan, DeAndre, Juliana, let's give them a quick G if you guys give with the two gradients. A half and, sorry, 2 and negative a half. Okay, cool. All right. Now the next part of the question. All right, so let's take that off. They want the equation of line L1 and then the relationship. Let's answer part 2 first. So part 3. What is the relationship between line L1 and L2? All right. All right, so the question is, so part 3, right? All right. So what is the relationship between line 1 and line 2? Now, what they're asking about here, in terms of the relationship, usually is if they're either parallel or perpendicular. Parallel lines have equal gradients. Are the gradients here equal? No, they're not, right? So parallel lines have equal gradients, right? Perpendicular lines meet at a right angle, which means that the angle between them would be 90 degrees. And on top of which, the product of the gradients of the lines is equal to -1. So if we take 2 and multiply by minus a half, what do we get? Right? So if we take 2 and multiply it by -1/2, what happens here? This is the next page, the part 3. I'm going to go back into the after. When they multiply out here, what you get? -1 over 1, which is just -1. What this means is that, therefore, these lines are perpendicular. these lines are mutually perpendicular, which means they are perpendicular relative to one another. Right? The product, the lines are mutually perpendicular. Product of their gradients is equal to -1, right? Perfect. Very good. Yes. Yes. Leandra. Not sure. I'm trying to figure out. All right. Yeah, so that's just a standard rule, right? When the product of the gradients of two lines is equal to -1, the lines are mutually perpendicular, right? Cool. Right now we're gonna do part 2 now, right? And I'm actually gonna I think I might copy and paste the diagram. Right. Okay. Right. Okay, so for part 2 to the question, which I bypassed temporarily, they're asking here, determine the equation of line L1. The equation of a straight line is the relationship between the x and y coordinates, right? The equation of a straight line is the relationship between the x and y coordinates, right? Now, we have a couple different ways we could state the equation, but normally, right, in my opinion, the most efficient one is the following, right? So the equation of a straight line, right, is y equal to mx plus c, right, where m is the gradient, right, which we know and have found, and c is, c is the y-intercept. The y-intercept is the point on the y-axis that the line passes through, right? So for line 1, if you follow the line here, it passes through 1 on the y-axis. For line 2, it passes through 6, right? Did I do the past from 2015? I would have done that some time ago. Actually, you might be able to find it on my Facebook page. If you go on Facebook and look for Adapt Tuition and go to my albums, you'll find Maths 2015. Yeah, that should be there. Pretty sure it's there. All right, cool. This year, no, I didn't do it this year. I usually start from the most recent exam and go back. Hey, Gabe, you did this in school today? Okay, nice. Right, so if they want the equation of line 1, right? So equation of line 1, right? Or L1, right? Now, do we have the gradient of line 1? From the previous working, what is the value? The gradient of line 1 is 2. And do we have the intercept for line 1? We'll call it C1. Yeah, it's actually just plain old 1, right? So all we have to do to state the equation of line 1 is put the value of 2 for M, and 1 for C. That's it. Right now, in this particular case, they gave us the intercept. So, so what used to happen before and what can still happen is you could have to find the intercept value, which we'll get to eventually. Right? So tonight we're just taking the questions that give us the intercept. And of course, we have to find the gradient and then just plugging them in. All right? So all you have to do is find the gradient, read off the intercept, and plug them inside of here. Right? The values of x and y will vary. Those won't stay the same. They're literally called variables for that reason. All right? Thank you. Good to see you. Thanks for the support, by the way. I appreciate it. So for practice, I want you all to do the equation of line 2. All right. So what would be the equation of line 2? Right? What's the gradient of line 2 from the previous page? Minus a half. And what is the intercept of line 2 given from the graph? Where is the line 2 partially y-axis? 6. Yeah? So all you have to do now is plug it inside of y equal to mx plus c. All right. So tomorrow for you have your math class,
Yes,
and then add maths after. Okay, cool.
I also realized when I was looking
I have the rest.
okay, so if you don't mind sending them to me.
Yeah.
Also, also I asked if and I assume that ferment is it not tangent, it's differentiation.
Usually,
Usually.
I seem to recall a question where we had to differentiate instead of integrate. I'll see if it's any solutions because it did that. Yeah.
Okay, cool.
Yeah. What time tomorrow? Sorry, not tomorrow. Tomorrow. Yeah, those stream on Tuesdays, do I? No, I don't. Yeah, my next stream is actually Saturday morning for Cape accounting. Maths would have been Monday again at 6:30, but we have a holiday on Monday. So unfortunately, the next stream is next week, Wednesday. But I'll see if I can do something for you all over the weekend. We'll see. Right, so what we got? Y equal to what? A half x plus 6. Right. You okay? All right, cool. Okay. some more Google Meet. So Donovan, D'Angelo, and Julius, give me a quick genie chat if you go with that, please and thanks. Crap. Hey, Namaya, thanks for the follow. Appreciate it. No. Why does it do that? Okay, cool. So, guys, what they're asking for here. Look at me. Okay, it's a little. Maybe zoom in a little bit more. Oh my god! Oh my god! Oh my god! Oh my god! Could you just? Oh jeez, this is so annoying. Right. All right, guys, this is annoying me, and I have to go upstairs real quick, right? So, long story short, all right, guys. I have to run upstairs real quick to get something. What paper is this one? Oh, this is the Jan 2019 paper. So they wanted to find the gradient of the line. Actually, no, forget that. They wanted to find the gradient and then the equation of the line, and they also wanted to find the equation of the perpendicular line that passes through P. All right. After run upstairs real quick to come back to get something. Yeah. So organize the gradient. You want the gradient first and then the equation.
Oh, I have a thing. We have to do. You have to know what to do. Yeah, yeah. Exactly. We mean I don't know what stuff like. Wait, I get one. I get one.
Okay, sorry about that. 2019. Yeah. January. Jan 2019. All right, yeah, guys. Next week then, right? I'll send a poll in the chat regarding Monday. Do you think? Right. So the graph below shows a straight line intersecting the x and y axes. Right. So we have, okay, bye Nyla. We have this point here. What axis is that? That's the x or y. That's the y. So that line is cutting the y axis, which means that is the what? The y intercept, right? Now 2, 3, 4, 5, 6. Okay, cool. So that is at point 4. So the y intercept of that line is 4. Right. Now the first thing they want is the gradient. Right? What's our formula for gradient? Y2 minus over x2 minus x1. Right. Now, we have one coordinate there. We could pick any other coordinate. The easiest one to pick is coordinate P. Right? Now, this one, let's call that C, right? The coordinates of C are 0 and 4. 0 on the x and 4 on the y. For that point P down there, we have 5 on the x and 0 on the y. Okay, bye, Haley. Bye, Christine, later. Right, so that's x1, y1. This is x2, y2. Right, so the gradient is simply going to be 0 minus 4 all over 5 minus 0, which gives us minus 4 over 5. Okay, we get through? All right, later. All right, next week then. No, actually, yeah, I think after today we're done until next term. Yeah, because next week is the first week in April, and the following is the last week of school. So. Oh, yeah, come. Oh, you and Caitlin, sorry. Thank you very much. Okay, bye. Yeah, boy. All right, sorry guys. Okay, oh, you get through your work. All right, cool. You get to escape. All right. Okay. Hold on. All right. Okay, cool. Sounds good. All right. Cool. Sounds good. Uh-huh. How do we fix that? Uh-huh. Mm-hmm. Right. Right. Oh, that's interesting.
Finished it.
Yeah. Cool. All right. You have any lessons in April for them? Yeah. I think today was the last day until May. Yeah. But then you'll have one class in April. Because the week after is the last week of school. I mean, if
Yeah, the 11th, you could be 11th
Yeah.
is the last week of school for this week.
yeah. But will they have
Or
any?
in this week.
Yeah.
No, maybe just next week.
Yeah.
Last class.
Okay.
We have a test next week.
Okay. Cool. Well,
We
yeah,
have a
we'll
conference
organize
again,
that.
so I'll do one more.
Okay. Cool.
And we could just
Yeah.
put it into me.
Yeah. Because I already sent people like last night notes for my class for like March, and I only did 7 sessions. But then Monday I might have a class because the babysitter coming. But like I didn't send out things for March already, like bills now. So I'm not sure what to do. But anyhow. Right, yeah. Okay, cool. All right, yeah. Yeah, folks, I said that's about it there. But you guys got that for the equation? -4. Okay, cool. The last one, the equation of the line perpendicular passing through P. Okay, so the perpendicular line passing through P, right? So the coordinates of P are same 5, 0, right? Now the gradient of the perpendicular line. What did we just learn about gradients of perpendicular lines? If you multiply them together, you get what value? -1. So if we have one of the gradients, like for example, we have -4/5 here, right? If we have one of them and you want to find the other one, you could transpose and solve, right? So right now you're multiplying. So how do we solve for it? We have to divide. So -1 divided by -4/5. Correct. Invert it and change. And a minus by a minus is a plus, right? So the gradient now of the perpendicular line is 5/4 and it's passing through P. And P has coordinates what? 5, 0. Now, if you plug this into y equal to mx plus c with the gradient of 5/4, y is 0, m is 5/4, then by 5 plus c. 5/4 by 5 will give us simply 25/4 plus c. And to solve for c, you'll subtract 25/4 from both sides of the equation. All right, so now we have y is equal to 5/4 x minus 25/4. Right, and that's the equation of the perpendicular line. All right. Okay, yeah, so D'Angelo, Juliana, Donovan. Yeah, well, Juliana gone. All right, that's about it, right? I had a cut and run, so sorry I can't take any questions, but they could always WhatsApp me. Okay, cool. Yeah, all right. Okay. I'll message you in chat about Monday, if anything, right? Okay. Right, so I'll go on there. Oh, I gone already. YouTube, anybody?